Hello, my name is Frances Paulish, and I am the head of the software initiative at Siemens Healthineers. And I would like to share in this industry talk our insights in accelerating modern approaches in global software engineering under the motto, "Pressure makes diamonds." Siemens Healthineers is a significant player in the healthcare industry, and it is very much a globally operating company. And in the context of this conference, it is perhaps particularly interesting to know that we have over 4,000 software engineers working for us globally in our products and solutions. We have a broad range of products. There is increasing digitalization throughout our portfolio. There's growing interconnections between the systems. We have both more hardware-oriented, cyber-physical systems in our portfolio, as well as cloud-based products. And so we need to be able to support different pace of change. As with many different companies, we have this accelerating innovation cycles. And of course, we're also often working in a regulated environment. And for this presentation, our focus is more on the software engineering aspects. So we have a strong focus on technical excellence, for example, the software craftsmanship topics. We have a broad use of agile approaches. The topic of software architecture is very well established. And these kinds of topics are also used in a training and qualification program throughout our company, so that we have a big investment in making sure all of our software engineers are using modern software engineering approaches. We also have a strong focus on automation. And of the 4,000 software engineers that I mentioned on the previous slide, over half of them are working in the Central Development Center of Siemens Healthineers and based in India and Slovakia. So we have a lot of experience over decades with the topic global software engineering. And the three topics I would like to address in this industry talk are the topic of agile, architecture, and automation. So the focus on agile is being able to optimize the entire value stream, being able to offer value quickly to the end customer, building in quality from the start, and this idea of speed, delivering this value fast, learning from that fast, being able to have fast feedback and data-driven decisions. And in this sense, we have very large, complex systems, but they need to also be agile and flexible, like the dancing elephant on the right here. And the topic of architecture really helps us enable this flexibility. There's a quote at the bottom here: alignment enables autonomy, right? If we have the right architecture for our systems, then we can have more autonomy and more agile and more flexibility in the various parts, but still have a holistically working overall system. So we try to reduce the dependencies between the parts of the architecture, structure the architecture according to the pace of change. So a part on a cyber-physical system is not going to change as fast as something on the user interface of a mobile tablet attached to the medical device, for example. And we have an explicit focus through our strong attention to software and system architecture, also on the non-functional requirements. So things like scalability, availability, performance, these kinds of topics, and not just the pure features. And the strong focus on automation is because we try to avoid the friction that comes from the handoffs between various so-called silos, right? Between requirements and the development and all of the possible sources of friction. We can, if we can automate them, reduce the negative impact of that friction. And automation also enables us to work with much smaller chunks so that we can actually focus our effort onto much smaller things which are highly automated. And this is much more effective way, but it can only be done if we have the appropriate architecture that avoids the dependencies between those chunks. And so we use automation to bring the cost of change down. And we do not want to hinder change. Change is good. That's why we have, we're always going with the change that's essential to business, but we need to avoid the negative impact of change, and automation is a big part of doing that. And then another advantage to the automation is we can learn from the insights of the automation, right? If we have all this information in our test cases, in our defect tracking systems, in our configuration management systems, we can do lots of learning, machine learning on this data, right? Applying artificial intelligence and machine learning approaches also to the data in our software engineering artifacts. And the motto of this topic is "Pressure makes diamonds." And what I mean by that, this is a quote by General Patton of the U.S. Army, is that we have lots of additional forces on us these days, right? We have increased digitalization. We have that software is causing even our cyber physical systems to become faster. Through the COVID-19 pandemic, we're having increased work from home, remote work, increased globalization. And all of these topics are causing a lot of pressure. And the topics that I mentioned, agile architecture and automation, are already well established and essential software engineering approaches. There's no question that they bring benefit. But the growing pressure forces us to focus on the essential value and to realize that most efficiently. And exactly these topics of agile architecture and automation are particularly good at enabling this focus on the essential value and being able to realize that in an efficient way. And one example I would like to show where these topics come together is the topic of continuous delivery and DevOps. And this is a slide sort of showing different feedback loops between the development and operations, where the customer more is, right? And the lower two levels here on this graphic are the traditional agile space. And the levels 3, 4, and 5 are more in the continuous delivery and DevOps space, where continuous delivery, you can see this fast feedback cycle goes all the way to being able to deliver that to the customer, but not actually going over that, crossing that line into the operations. And continuous deployment is actually doing that agile all the way to the end customer. And continuous operations takes that a step further. This is typically more in the cloud space rather than in the cybersecurity, the cyber physical systems kind of space. So this continuous delivery and DevOps is more prevalent, of course, in the cloud area. And the topic of continuous delivery and DevOps basically allows us to make a transition from the top part of this picture on the right to the bottom, that instead of having projects that are delivered every 6 months or every year, we're able to, if we have the appropriate processes and architecture and automation and culture, if we can change that to being much more frequent deployments of small updates and enhancements, per feature, have a continuous value stream, and being able to do this much more often. And this brings a lot of benefits, as I'll show on the next slide. But this requires a high degree of automation and the appropriate processes. We strive to keep the system in a releasable state continuously throughout the development, supported also by the automation. And this way of working also has the huge benefit. It brings a high degree of motivation, right? You have the possibility for success, every day rather than once a year, right? And culture and mindset are extremely important in this space. You have to get everybody working in this way, in this tact. And it's very efficient, but it takes a lot of work, and it's a long journey to get there. And this is an overview of the benefits of such an approach, basically showing according to those 3rd, 4th, and 5th layers of my first picture in this, right? In the continuous delivery, if you're able to deliver the customer value with higher quality in time, is on that 3rd level. And if you get into the continuous deployment space, where you're actually crossing the line to delivering it to the customers, so typically in the cloud space, that you have the benefit of this value to the customer of being able to deploy that, or keeping your up-to-date cybersecurity and your improved availability, or at the topic at the bottom, the reduced deployment and operational risks. If you're releasing 1,000 lines of code, that is much easier and less risky than if you are releasing 1,000,000 lines of code, right? You have a much better clear understanding, and you have these much smaller chunks. So you have release can become a non-event because they're such small chunks that you are actually releasing, and all of the appropriate tests and validation that you have to do is done beforehand, of course. And then if you get into continuous operations space, you have much more possibilities for data-driven decisions and being able to do things like A/B field experiments and to further improve the product based on, for example, how your customer is using the system, which features are they using most, and feed that information back so that you can further invest in features that the customers are using, and maybe not so much the ones that they're not using. And so the key takeaways summarizing here is that this software world, the globe, is turning faster, and that pace is accelerating. And so we need to apply modern software engineering approaches that helps keep us up to date with that fast pace of change. And these approaches allow us to work in a holistic and automated way and enable us to have these many small chunks of work and being able to deploy individual feature after feature after feature. And in order to do this, you have to have this right mix of autonomy and alignment to be able to have that positive impact. And this is important to be able to have a way of working that is not only effective, but also very resilient to various unexpected challenges like we are faced with today. And most important at the end also is that we need to establish and nurture a culture and a mindset that is open to change and welcomes these opportunities to learn. So I thank you for your attention. I hope that this summary of our industrial experience in this space and global software engineering was of interest to you, and I look forward to questions in the subsequent online forums.
Thanks, Carol.
Hello, my name is Frances Paulish, and I'm the head of the software initiative at Siemens Healthineers. And I would like to share some of our insights in this industry talk on accelerating modern approaches in global software engineering under the motto, "Pressure makes diamonds." Siemens Healthineers is a major player in the medical technology area. Here's some numbers describing some aspects of our company. In particular, we have about 4,000 software engineers in our company. And this slide shows that we have a broad range of products. We have a lot of software and digitalization increasingly in our products. And there is a lot of interconnections between our systems, and also the need to support a different pace of change, right? Some of our products like scanners have a lot of hardware involved. Other end of the spectrum would be some cloud-based products, so software only. And in all of these cases, as in many of the companies or organizations where you work, we have a lot of accelerating innovation cycles. And so the world is moving faster and faster, right? And the world is getting smaller all the time. And in our case, we are also working in regulated environments mostly. And this makes some of the aspects as a special touch on how we address some of these topics. And at our company, we've had a strong focus on software engineering and also on global software engineering. So we have a strong focus on technical excellence in our software engineering top areas. For example, software craftsmanship topics. And also topics like agile and architecture are very well established at our company. And we have a specific training and qualification program that we call software curriculum that sort of teaches this way of working and also sort of the social aspects and the culture aspects that are important in this area. And as I mentioned, we have about 4,000 software engineers worldwide working on our products, and over half of them are working in what's called the development center part of Siemens Healthineers. This is also where I am based. And most of the development center is active in India and Slovakia. And this has to do also with our strong focus on global software engineering. And in the talk today, I would like to show how some of these topics that I mentioned, agile, architecture, and automation, really help. They're great techniques anyway, right? They're very well established software engineering techniques for any modern software engineering projects. And they are also particularly useful in the global software engineering space. So this is sort of one slide showing the dancing elephant on the right here to highlight the balance that is needed between stability and agility, right? We need to have the right mix, as is also quoted by Jim Highsmith down in this quote at the bottom left, of having a stable, long-term approach, but also having the flexibility to have fast value to the customer. And we need to be able to learn fast and have very fast feedback, and ideally having these decisions being based on data. And so we tend to have, because of the trend to agile and this speed topic, we tend to work in much, much smaller chunks than in the past. And you'll see this a little bit as a sort of a common thread through the presentation. The other A here in this area is the topic of architecture, right? Being able to, through architecture, reduce the dependencies between the parts of the system and thus enable that they can each be developed on separately from each other, at least as to the extent that it is technically and makes sense, it's feasible to do so. And so we also, in this same reason, we often consider to structure the system according to the pace of change, so that the hardware parts would change much slower than, for example, some user interface aspect on a mobile tablet that's attached to the hardware device, for example, right? And would have those being updated and developed and having newer features at different pace of change. And also in this sense, it's not by chance that we have really containers in this picture, right? So the containers is also a technique that is used to be able to reduce the dependencies between parts of the system. And in the sense of global software engineering, I really like this quote at the bottom here about alignment enables autonomy, right? If we can structure our systems so that they can work to a specific extent independently of each other, that will enable the autonomy, and that will then further enable speed. And another enabler of speed is the topic of automation, right? Where do we lose time? Where do we have the sparks flying? That's in the friction between the silos, right? In this old picture of a mill with the silos and the information going from requirements to design to implementation to test and so on. There's so much that can go wrong at those interfaces that if we can get smaller pieces, chunks of work going across those silos and have that being done with automation, then we have almost by definition much less friction. And this also enables us to have a huge amount more of transparency, and transparency also avoids all of the sort of uncertainties that might come into place. And this automation also enables the smaller chunks of work that I mentioned when talking briefly about agile. And showing down here this picture on the bottom right here about waterfall versus more agile approach or DevOps, the whole point, one of the major benefits of doing more continuous, more agile, and agile on steroids is more continuous or DevOps way of working, is that you reduce the cost of change, right? Because, in some cases you want, in the old days, say with waterfall, you would try to avoid change. You would try to plan everything up front because change is so costly. But if you can change that equation, if you can cause that cost of change to not be so high, this enables, it sort of unleashes this whole much more powerful way of doing modern software engineering. So we use automation to bring the cost of change down, and we especially want to avoid the negative impact, the cost of change, but do not want to avoid change as such. And another advantage of all of this automation, which I will not be going into in more detail in this presentation, is that we can learn from the insights of automation. So we can do things like applying data and machine learning, for example, to all the data. And so all of these three topics are causing forces to be addressed to us, right? And there's forces on different sides. We've got more digitalization. The speed is coming much faster. We're doing much more work from home. The situation, for example, with the COVID pandemic is causing more work from home or challenges in the workplace. And all of this pressure is enabling us also to focus on the essential value and realize that most efficiently. And so that's why I chose this quote, "Pressure makes diamonds," from General George Patton of the US Army. And in this example on continuous delivery and DevOps, this is a classic case where agile architecture and automation all come into play here. So agile is sort of this bottom two layers on this picture, and continuous delivery and then further into DevOps are sort of the higher parts of this picture. And basically, we're trying to get from the old way of working, this sort of 1 year kind of cycle, to this much faster way of working, a continuous value stream that requires this high degree of automation, try to keep the system in a releasable state. And this is all the kind of way of working that we use in a modern approach. And this is also what brings us benefits for the development and also for our customers in these various ways. But it also enables a better way of working also in unexpected situations like we have today with the corona pandemic. So the world is turning faster and the pace of change is accelerating. Applying modern software engineering approaches that enable you to work in this holistic but automated way, and especially with these smaller chunks of work. This will help us, no matter what kind of software we're developing, if we can structure things in that way that we can handle these smaller, more independent and in an automated way chunks of work. Having the right mix of autonomy and alignment, the architectural considerations will have a huge significant impact on how well we can do this or how difficult it will be. And we always need to strive to establish a way of working that is not only effective, but it's also resilient to any kinds of unexpected challenges that might occur, right? There's always that next challenges are going to be coming. And especially we need to establish and nurture a culture and a mindset that is open to change and welcomes opportunities to learn. And so I hope that this insights into our approaches at Siemens Healthineers in this space on modern software engineering, especially applied to global software engineering, was of interest to you. And I would like to go on now to the question and answer sessions in the chat. Thank you for your attention.
Thank you very much for that. We have about 2 minutes until the next talk will start automatically. So in the chat, we have a question here. Can you possibly elaborate a bit more on which of the challenges mentioned can be solved with the work practices that you've shown and which still need to be addressed?
I think the automation and the transparency are really one of the best ways of sort of bringing the various parts of the world together for global software engineering. And I think also perhaps it's also very interesting for persons in other countries who have not experienced working remotely like we typically do with the global software engineering to experience that in their own meetings, right? And the fact that people in Germany and the US and other countries also have to do a lot more work online, it also brings more sympathies for the situation on doing global software engineering. I think we're all equally affected by the topic.
I have a question. You mentioned culture change. How much culture changing did you have to do, and how difficult was that? And was it really difficult to get started on this whole process?
Well, we have a very, very long history in the global software engineering space. And so a lot of that culture change grew already over a long period of time. So we didn't have to make so much change more recently. But it is extremely important to get everybody on the same page, product management, and not just development, but the whole company, all roles.
Okay, we have about, well, we have 15 seconds. So I guess there will be a discussion breakout room where we can continue with this, or you
Okay.
all, and then we'll go on to the next talk, which should be popping up automatically
Okay.
right now.